Hey again there, guys. On slide number 61, in the example of mass-to-mass stoichiometry, we're asked to calculate the mass of carbon dioxide produced when 5 grams of butane is burnt in excess of oxygen. As with all stoichiometry calculations, we need to start with a balanced chemical equation. So butane is C4H10. When burnt in oxygen, we assume complete combustion, the formation of CO2 gas and water in its gaseous state. If we're balancing this equation, we're looking to make sure that we've got the correct amount of each element. So we're going to need 4 carbons. We're going to need 10 hydrogens. Here we've got 8 plus 5 makes 13. So this will be 6.5 oxygens. Now we don't usually use non-whole numbers here, so we're going to multiply everything by 2 to get 2, 13, 8, and 10 for our balanced reaction for the combustion of butane. Now we were given in the question that we have 5 grams of butane, so we have 5.00 grams of C4H10. Our first step is to convert this into moles. So we always want to convert our given substance first into moles. So moles of butane from grams of butane. In this case, the molar mass of butane is 58.1234 AMUs. So 1 mole is 58.1234 grams. Our grams will cancel. So now we've solved for moles of butane. But in the question, we're solving for carbon dioxide. So let's convert moles of butane into moles of CO2. There are 8 CO2 formed for every 2 butane. This can be reduced to a 4-to-1 ratio. Now we've got moles of CO2, but we were asked to solve for grams. So grams of CO2, we'll just put a little border there. Grams of CO2 from our moles of CO2. 1 mole of CO2 is 44.0098 grams. Our moles of CO2 will cancel, and we've now planned out our entire calculation. Let's punch it into our calculators. So we've got 5 divided by 58.1234. We're going to multiply that by 4. And we're going to multiply that value by 44.0098. That's the mass of CO2 produced.